Oh, hi. Good day, everyone. My name is Ram Posham. I'm a cloud architect with Oracle for many years. I'm a data platform advocate. So today I'm going to show you an exciting feature called AutoML that comes with Oracle Autonomous Database. So in Oracle Cloud, Oracle offers something called Autonomous Database. It's a self-managing, self-tuning, and self-securing database, which means there is minimal to no effort that database administrators have to spend for managing the database. All right, they still have to, of course, focus on schema design and also how to get the best performance out of Oracle database. All that, yes, it's still valid, but it's an autonomous database. Anyway, so today I'm going to be just focusing on this AutoML capability. So let me define the problem that we are going to solve, okay? So here, let's imagine that we are working for a company that sells insurance policies, and it has lots of historical data of customers who purchased insurance and who have not purchased the insurance. So what we will do is, from this data, we are going to extract a subset of the data that contains both customers that purchased insurance and did not purchase. A small, this may be millions of rows, but you're going to get a small subset. And from that, that's going to be used for creating a AutoML, a model, right? Machine learning model. And so we create the model. Then we can validate the accuracy of the model. How accurate is that particular model that is created using the same data set that was used for creating the model. So that's what we're going to do. Then after that, once we are happy, then we are going to use this model that we created for the rest of the data. That means we are just going to pull all the customers that have not purchased the insurance from here and apply that model on that. And then we are going to get a list of customers that are likely to purchase the insurance. Again, in machine learning, there are three ways. There are primarily two machine learning techniques. One is called supervised learning, wherein you present the data that this is the kind of data, these are the kind of customers that purchased the insurance. These are the customers that, these are the types of customers that did not purchase the insurance. So, and that is used for creating the data, for creating the machine learning model. So think of like this, right? This is a good analogy I can think of. If it walks like a duck, sounds like a duck, and looks like a duck, it's very likely that it is a duck, right? There's high probability. Same thing. So if you know that so-and-so customers living in so-and-so cities with so-and-so education, earning power, all that, purchase the insurance. So when you have other customers that are close to that profile, then you can say they are very likely to purchase the insurance. But the good news is with AutoML, that is comes with Oracle database in the cloud, autonomous database, it's very, very easy. You don't have to write a single line of code. So I have customer insurance historical data. From that, I'm going to be using a SQL. And then I'm going to create a trained data set. Then I'm going to create AutoML. I'm going to create a machine learning model using AutoML capability of autonomous data warehouse. Then I'm going to validate that particular model for accuracy. Then after that, I'm going to use the data here of all the customers that did not purchase the insurance, apply that on this model, and then get the likely customers. And that customers list could be used by the marketing department. So that's the demo flow. All right. So these are the customers who did not buy. And so essentially, it's just a SQL statement, right? That's a SQL statement. And then this is the likely customers. Okay, moving on. So the customer table, right? This customer insurance ML trained data set has many, many columns. Customer ID, last name, first name, and so on. And it has got age, has children, salary, and so on. And so on and so on. But there is one column which says buy insurance, and it has got two values. By no, that means that particular customer did not buy the insurance. And if the value is yes, that means that particular customer purchased the insurance. So every customer has a unique ID that you can see, all right? And so in this demo set, I have about 15,000 rows, and that's what I'm going to be using, all right? And we are going to create a machine learning model. So it's very, very easy. What you have to do is you just provide the table name and what is the unique ID, and sorry, what is that you are predicting, and what is the unique ID for that row, for the table. All right. So then it's going to, you can select the number of models that you want to use, and it's going to build a model. So you can think of this on the horizontal axis, how many attributes matter for the accuracy. So there are few key attributes that matter, and after that, it doesn't matter how many attributes you have. So that's what, but you see in this screenshot, there we used a random forest, decision tree, and so on. And this is the accuracy that you get. All right. And this gives you the attributes that were impactful, that were more relevant for predicting the customers that are likely to buy insurance. Okay. So without, again, there's something called confusion matrix. It gives you the accuracy of the model. So customers, it is predicted as no, but actual value in the table is also no. That is 60% of the customers. Then the 21% is the predicted is yes, and the actual value is also yes. So you can see 81, more than 81, 82% accuracy. These ones are false positive and false negative. That's what it is. So I'm going to show you a quick demo. So let's jump into the demo. All right. So you can sign up for Oracle Cloud, a free tier. With that, you get 2 autonomous databases and 2 VMs. And as you can see, I'm going to be using my own free tier. So I'm logging with my Gmail ID, and I go here. So in the database, so you got autonomous data warehouse, and I already have a database, but if you want to, in your free tier, you can say create autonomous database, provide the compartment name, display name, and so on. And then you can say, show me free tier, and with free tier, you get 1 OCPU and 0.02 terabytes. That is 20 gigabytes, actually. 20 gigabytes is plenty of storage. And you get a predefined user called admin. It's administrator, and you specify the password 2 times. And then you can secure the access from anywhere. So here, what you do is basically you can allow the users to access using the credentials. But here, if you want to provide your, let's say, a particular IP that you want to access it from. So here you can enter whatever IP you want, and so on. So it's very, very easy, excuse me, to create an autonomous database. And so I'm not going to create, I already have one. I'm going to be using that. So here is the autonomous database. Then you can go to database actions. And so it's going to show you what all you can do. Basically, you can use SQL worksheet, you can create data modeler, and so on. But let me, before I go for modeling, a machine learning model, let me create a user. So let me create a, let's call it ML demo. All right, ML demo, and the password, whatever password you want to. And we are going to be using web access. And I'm going to allocate some space for this user. And I'm going to be using machine learning, right? And that's it. It's very simple. Create the user and then ML demo, right? So now you go here and just log out from here. And you log in as ML demo, next. And specify the password. So very, very simple. So very quickly. So now you can see I got all these tools that are available. And so that's what I would do. Then go back here to the autonomous database. And I go to, for machine learning, I have to use service console. So go to the service console. And, for the demo, I would be needing, just hide this panel. Yeah, so I would be using, so for example, development, go here and there, then you log in as using the machine learning interface. So that's it populates that ML user, ML demo user, okay? So just sign in. All right. While this is coming, now we need data, right? So we will go here. Okay, we'll come back to this tab in just a minute, but let's go here and load the data, right? So there is a data loading. So data loading, and I want to load it from a local file, all right? So next. So we'll just drag and drop a file. I have a file that has data. So this is the file. By the way, I'm going to be sharing all the data, demo data, and some of the SQL that I'll be using. So that's data. I'm just going to be loading it, run it, right? It takes a few seconds to load about 16,000 rows. And after that, we will go back and machine learning, okay? All right, so that is done. So let's go back to this one. So now, to save time, what I've done is I've created a notebook. So let's go to notebooks first, and then we will import a notebook that I created for running a few SQL statements. Okay, so let's import actually here it is, machine learning. So that's the JSON file I have. So you can create a Jupyter notebook. So I already done that for you. So click on that. I will explain what I will be doing in just a second. So it's going to take a few seconds to start the notebook server. In fact, if you want to pause or fast forward for a few seconds, you can do that. All right, so here is the one. So what you do is essentially look at the sample data, right? So this is the customers table that we loaded into the schema. So if you want to know, just let's run this SQL. So you can see that's the name of the table actually. So it's going to just okay, it's running. So just give it. First time it is a little slow, but now you see the customer ID, last name, and so on and so on. If we go to the right, there is one attribute you can see buy insurance. So there are some customers who did not buy insurance. There are some customers who bought the insurance, right? So that's what this one is. Then go down to the next SQL. Say you want to know how many rows are there in this table, correct? So just say That was just a sampling of the data, customer insurance. And here from customer insurance LV history. So let's run this one. See, there are 15,342 rows. Go to the next one. So what I would do is I just want to look at how many customers out of those 15,000 customers, how many customers bought insurance, how many customers did not buy, and what is the total number of customers. So there's a query here, and I'm doing a count on that, right? This is a subquery within that. So you can review that SQL later, but let me just quickly run this. So it just gives you, so there are, out of those 15,000 customers, 4,000 customers bought insurance and 11,000 customers did not buy the insurance, all right? So go down. Then the next thing is, I'm going to create a training data set, all right? So just to repeat, I have this one, but basically we are going to create a data set, and here is the sample percentage, and it's going to prompt me actually what is the sample percentage. So let's run this, and it's going to prompt me what is the sample percentage I want to use. So that's what this one is. So let's run that. See this one, I use 30%, that's the value. And now it created a table called customer insurance ML train data set. It's basically customers, right? So here, what, not that one. Within that script we had, yeah, see this one. So we are just saying select star from this table, and we are sampling whatever that percentage. So that percentage was 30%. And then we are also listing how many customers bought insurance. Out of those 4,570 customers, 1,242 customers bought, 3,328 customers did not buy, and this is the total count. See, this one and this one are matching. Now, what we will do is we'll go to AutoML and create the machine learning model using this train data set. All right, so we just go to this one. Sorry, here. Let's go to the main thing. So this is the AutoML. And then let's create a model. So here, let's call it predict insurance buyers. All right. And then you can just, if you want to put some comments here, you can do that. So now, see, what it's asking is what is the table that you want to use for training. So it just give me, so these are the tables. This is the one which had 15,000 rows. And from that, we created this small table, about 4,000 rows. And so that's the table we are going to be using. That contains a smaller data set for training. And then it says, what do you want to predict? So I want to predict buy insurance, right? So this is what I want to predict, and what is the unique ID. So that's what the unique ID is. And if you want to set, there are 5 models. By default, it picks. But if you want to just start with 3 models, you can do that. It's left to you. And you can specify the duration of the execution. You can put a limit on that. And you can say start, and you want faster results, you can do that. So this is actually going to take just about 2 to 3 minutes. So what I would do is, let me pause the video. Let's just pause the video. Pause the video, okay. Pause record. So it took about 2 minutes. It is basically selected, it's 3 models based on the data. So random forest, naive Bayes, and neural networks. And different models have different accuracy, but you can see it is actually tuning the models. So it should be completed in another few seconds. So let's see, it just took 2 minutes. A few more seconds. Neural network. And while that's going on, actually what it does is it, for each model, it tells you what attributes or what features are important for this prediction. So it's going to tell you. So let it complete that. It's still working on that. Still running. I think this is the final one. So feature prediction impact. So this is where it actually finds out what features are more impactful. All right, so just, okay, looks like it's completed. No, almost completed. All right, so it's completed, right? It took about 4 minutes, actually, 3 plus, close to 4 minutes. Now you can see for this model, random forest, it says it is, the probability of buying insurance depends upon these attributes of the customer: bank funds, number of mortgages, money monthly overdrawn, and so on for this particular model. If you go to neural networks, it says it's predominantly decided by the number of transactions at ATM, bank funds, and so on. All right. And if you look at naive Bayes, again, it says it's a number of transactions on the ATM, money, monthly overdrawn, and so on. So these are the attributes that are governing the prediction, right? So here is a confusion matrix I was talking about. So when you add these two numbers, 61 and 17%, that's a total accuracy. So here, it so happened, actually, yeah, here for random forest, for the random forest, it says bank funds, monthly overdrawn, and the payment amounts, right? Automatic payments. These are the factors that govern, that control whether a customer is likely to purchase insurance or not. So, and look at the accuracy. So 58 plus 23. So when you add that, it comes to about 81, 82, actually 82%. All right. So that's good. Now let's go back to this one, the notebooks, right? Here, let's go to the notebooks. And we were already there, so let's go back and do some additional validation, like how accurate is this model, things like that. I'm going to show you using SQL. Okay, so it's loading again, the notebook. So we already executed a bunch of steps here, and we went to, so here, so we finished that machine learning model. Now, what we will do is, now we are going to check the accuracy of this particular model. So it's asking for this takes the model name as the parameter, all right? So now I need to know what are those models. Let's see this. Okay. I should have copied the model name. So let's pick this random forest model, right? This is the most accurate one. So let me copy that. You see RF636 ending with 152. So that's what I'm going to be using. Go to notebooks again. Here we go. Okay. Okay, right. So let's go back to, so we completed machine learning model. So here, what we are doing is we're just checking we are actually selecting from this particular model. So what is predicted and what is the actual value? And we are using the trained data itself. So we are applying this model on the trained data set itself and finding out what is the accuracy. So I need to run this, obviously. So let me run this. I'm going to be entering the actual model name. I should be entering the model name here. Where is the model name is, here, sorry. Here is the model name. See this one. So this is what, so it says model is not exist because this is from my old demo. So let me enter that. See this one, 9152 ending with. So let me run that. Run it. So it's finished. So now you can see this is the customer ID and this probability likely to buy it's 100%. So that's yes and yes. Predicted is yes. Actual value is also yes. So you can see it's going from the descending order, 99%, 99%, and so on. See, so it's predicted by insurance is yes, and actual value is also yes. But you will also notice in few places where the predicted is yes, but actual value is no. See this one? Here is the one. It says this customer with ID CU11014, 86% probability. Yeah, it's predicted is yes, but actually this customer has not purchased the insurance yet. But it says prediction is very likely to purchase the insurance. So this is very likely candidate, correct? So the customer, so that's very, so the prediction, this is prediction and this is the actual value. So that's like false positive. That means the customer did not buy, but we are saying it's likely to purchase the insurance. But again, we can use this data for marketing, right? So that's the one. Then keep going down here. Let's check the accuracy of the model. Here, what we are doing is the false positive and false negatives and so on. So that's what we are doing. So let's run that here. So let me run that. Okay, so it's again looking for the model name. So that's the one. Actually, I need to update the model here. Unfortunately, Jupyter Notebooks does not allow me enter global variables. So anyway, I had to enter one more time. So that's one. So here it says accuracy. You can look at this. It says predicted no, actual no. That is 3,000 customers, 3,188. Predicted no, actual yes. That is false negative, right? Predicted no, actual yes. So false negative is 420. Predicted yes, but actual value is no. That is false positive. So there are 267 customers, but predicted yes and actual value is yes. So 828. See the accuracy, 828 plus 3,100. So that's the out of the total, right? If you add this, so this is the accuracy, 3,188 plus 828 over this entire total. Right? That's a percentage. Now, if we want to, the same thing, I just want to compute the percentage. So just run this and it is going to compute the percentage. So that is 89% accuracy, which is fantastic, right? We have not written a single line of code. So all these SQL statements are there. Now what we are going to do is we are going to apply this model on the actual data, right? So what we will do is from this historical data, we are going to create a table of those customers that did not buy the insurance. You see this one? Create this table from this historical data of customers who did not buy the insurance. So let's execute that. So that is completed. And then let's see how many rows are there in this table. So there are 11,183 customers that did not buy the insurance. Now we will apply this particular model that we created in few steps back. All right. And this is for repeatability. That is customers likely to buy insurance. And so that one, so we're creating a table as select from this one. So you see, we are applying that particular model here. So let's run this. Again, it's going to prompt me for the model name. So let's run this. It's going to error out as expected because it's expecting this parameter value. So see that one, this is the model name. So run this. Now you can see it completed that. And now let us select sample data from this particular table. So let's run that. So here you can see these are the customers that are likely to buy insurance. Customer ID, customer name. And so we can provide this data set to our marketing folks, right? So how many customers are likely to buy insurance? So that is 746 with the new sample data, all right? So out of those 16,000 customers, we can, instead of targeting those 16,000 customers, we just target these 746 customers because they are very likely to purchase the insurance. So your marketing dollars can be spent much more effectively on these customers, all right? So that is what I wanted to demonstrate. And I'm going to provide you this JSON file that basically the Jupyter notebook and the sample data. You can find the link in my notes section. And I wish you all the best. And if you have any questions, you can contact me. And that information is also in the notes section. You have a good rest of the day. Thank you and bye-bye.